Hi and welcome. So, a little bit of a backstory. A while back, I created a cluster on Amazon. As you do, created some services, played around with CI/CD, GitHub Actions, and what have you, and then I forgot about it. A month later, Amazon graciously gave me a bill of $200. So it got me thinking, why not make a cluster at home? Because this is not sustainable. As a startup, sure, small money, but it's not even a big cluster, like two EC2 servers and not a big one. That. So I went to the internet and the internet said, hey, pal, you should use Raspberry Pi. Lots of Raspberry Pi clusters out there, tutorials, YouTubes, what have you. Now, I can get them. They're out of stock basically everywhere. I can get them from Amazon for $200+, and yeah, I don't wanna. So instead, I've decided to take the hard route, create a cluster from old PCs. I don't have enough old PCs. So this is a NUC, if you're not familiar. It's an Intel PC, small one. It has a CPU, motherboard, a bunch of IOs. It has no RAM and it has no hard disk. You need to supply those yourself. And this one is Celeron, basically the cheapest one I could find. With the RAM, with the hard disks, it's still cheaper than Raspberry Pi from Amazon and also much, much faster. Additionally, it's x86 architecture, which means I don't have to make sure that all the services are running on ARM. Some of them aren't. Istio, for example, is only recently have full support on ARM, so that's a huge bonus for me. So I got a few more. Um, Basically, here's the plan. So I have this, which is the weakest Celeron I have, which I believe is N4005 CPU. Basically, it's going to be the master. And those three guys are going to be the worker nodes. So I got all the memory I need. Believe it or not, those are like $8 a pop. And I got all the hard disks I need, which are those, $15 a pop. And that's basically going to be my core cluster. Additionally, I have found, lying around, this little feller. So this is something, it's called Mini PC. It's ZW83 or Z83W. It's a very old one, and I'm going to use it as a router. Now, if you don't have um, those, you can use old PCs, and I do intend to reuse some of my old PCs. I have an old Asus laptop. This guy, it's quite old, as you can tell. And I also have an HP Pavilion, which I'm using as a stand for things. And it's old, it's a decade at this point, but it's plenty enough to run low intensity applications that require a lot of memory or RAM. So I'm intend to use that. As far as things surrounding the cluster, since this one has only one Ethernet port, and for it to be a proper router, I need two, I got myself a USB adapter thing. And for the other connections, I'm just going to use a small, tiny TP-Link, which has 5 ports, which is enough for most things I need. Now, since I have a 3D printer, I also made this, which I'm going to house everything. And it's going to use one power supply to power the whole lot. Small screen, and of course place to put everything. But that's another video, part 2, maybe 3, I don't know. It's gonna take a while. Now, that's all the hardware that I need. Now, as far as the architecture of the things go, this is where I need my whiteboard. So here's my plan. I intend to have my internet connection connected to my improvised router, which called Z83. From there, it's gonna go and create a network for the switch in which all the cluster will connect to. So you're gonna have a master, have a node, 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 and old PC over here. Now, it looks simple, but this guy over here is where things get really, really complicated. Okay. So here where the fun part begins. So if I go from the internet to here, I'm gonna hit my router, the home Wi-Fi router. Here, I want to forward traffic to my improvised router, the Z83 mini PC. And it's going to have a couple of hats to fill. First of all, it's going to have a VPN on it. I want to be able to connect to my cluster securely, remotely, from anywhere. Additionally, it's going to have something called Rancher. Rancher is basically a Kubernetes cluster manager, which will allow me to easily deploy and manage my cluster without EKS, Amazon, or other interventions, and with less DevOps stuff for me to know. Furthermore, it needs to have an internet gateway or something called NAT gateway. Basically, forward all the traffic directly to all the cluster nodes on the network. So we have a master here, node, node, node. And final thing, and that's why this whole thing is so complicated, is to be able to secure traffic in case somebody does inevitably get into my cluster. So this network is segregated. And the only way for it to go and reach my home PC, imagine this is a home PC, is to go through this server and somehow reach here and go here. Now, since I have a NAT gateway, I can have a firewall, and basically this is my security device, right? Yeah, that's gonna be fun. So let me mark this one as master so I won't forget. And let me speed things up. That's gonna take forever. And by the way, for whatever reason, some of them come with this cable, some of them without. Now I need 3 more cables. So I have enough cables. Let's put those aside for now. I'm not supposed to open that. Cool. When you open, be careful. Now that this is done, let's test one. On. Okay, see what's going on. Oh, that's not good. Maybe that's not the cable's fault. Okay, cool. So we have a bootable device. And now all we need to do is install OSs and things. So that's pretty much it for the hardware. Now the next steps are going to be installing the operating systems, configuring things, and that's going to be a long video. I'll see you in the next one.